220%. That's how much the share price of a California-based chip company climbed in a single year, making it the best-performing stock in the S&P 500. And yet, for most of the world, its name barely registers. This is NVIDIA, a company that quietly sits beneath Netflix, Adobe, NASA, Google, Amazon, and even the factories that make your breakfast cereal. A company whose technology powers modern artificial intelligence, cloud computing, robotics, and the infrastructure of the digital economy itself. NVIDIA doesn't sell products you usually touch. It sells capability. And that's what makes it one of the most influential companies of the modern era. To understand how NVIDIA reached a $1 trillion valuation, you have to go back to a very different time. The early 1990s. Personal computers were slow, beige, and functional at best. Rendering graphics was simple. Text, windows, and the occasional image. Anything more advanced was handled by game consoles or expensive professional machines. Most people believed the central processor was enough. 3 engineers disagreed. Jensen Huang, Chris Malachowski, and Curtis Preem believed computers were being asked to do too much with the wrong kind of hardware. They saw a bottleneck forming long before the industry did. CPUs were generalists. But graphics required repetition, parallelism, and raw mathematical throughput. Their idea was simple but radical for the time. What if graphics had their own processor? In 1993, inside a small California condo, NVIDIA was born. The name came from next version, and the Latin word for envy, a nod to the computing power they hoped would make others jealous. But ideas alone don't build companies. The founders had talent, but little money. In fact, the company's incorporation was funded with a few $100s pulled from a pocket. What changed NVIDIA's fate was trust. Jensen Huang had previously worked at a semiconductor company called LSI Logic. Those relationships opened doors to venture capital firms who had seen results before. Against long odds, NVIDIA secured $20 million in funding, a staggering amount for a startup entering an already crowded field. At the time, nearly 90 companies were racing to build graphics hardware. Almost all of them would disappear. NVIDIA's first major product arrived in 1995. It was ambitious. Too ambitious. The chip attempted to do everything at once: graphics, audio, video, and more. Internally, it was complex. Externally, it was incompatible with where the industry was heading. Microsoft had just introduced DirectX, a software standard that reshaped game development overnight. NVIDIA's chip didn't support it properly. Developers moved on. Customers returned their hardware. Inventory piled up. Within 2 years, NVIDIA was on the brink of collapse. Half the company was laid off. Millions of dollars were effectively burned. This was the moment most startups never recover from. NVIDIA survived because it did something rare. It admitted it was wrong. The company abandoned its original architecture, scrapped years of work, and rebuilt around what developers actually needed. That pivot led to a new focus: dedicated graphics cards for personal computers. In 1999, NVIDIA released the GeForce 256. It wasn't just successful, it defined an entire category. For the first time, graphics hardware was marketed as a processing unit in its own right. The term GPU entered the mainstream. Within a year, NVIDIA went public. Soon after, it secured a major deal to supply graphics hardware for Microsoft's Xbox, a contract that injected hundreds of millions of dollars into the company and cemented its place in the gaming industry. But NVIDIA's most important decision came quietly. Instead of manufacturing chips itself, the company chose to focus solely on design. Production would be outsourced to the most advanced foundries in the world. This fabless model kept costs low and flexibility high. One partner became especially critical: TSMC. For decades, NVIDIA relied on Taiwan's manufacturing expertise, while directing its own resources toward research and software. That decision would later define the AI era. In 2006, NVIDIA introduced something that didn't look revolutionary at first: CUDA, a software platform that allowed programmers to use GPUs for general-purpose computation using familiar programming languages. Before CUDA, GPUs were powerful but difficult to use outside graphics. After CUDA, they became accelerators for any task involving massive parallel data. The implications were enormous: scientific computing, data centers, machine learning. But the real breakthrough came in 2012. A research project called AlexNet used NVIDIA GPUs to train a deep neural network on over 1 million images. The results shattered expectations. Error rates dropped dramatically. The AI winter ended, and NVIDIA found itself at the center of a revolution it had quietly prepared for. When generative AI exploded in late 2022, demand for NVIDIA's hardware surged overnight. Data centers raced to secure GPUs costing tens of thousands of dollars each. Entire infrastructure strategies were rewritten around NVIDIA's technology. Revenue doubled. Market value soared. In 2023, NVIDIA crossed the $1 trillion mark. But success brought controversy. Cryptocurrency booms distorted GPU pricing. Gamers were priced out. Investors accused the company of downplaying risk exposure. Regulators stepped in. Partners walked away. Even today, critics question whether NVIDIA's growth is sustainable, or whether competition from in-house chips, geopolitical risk, and rising costs will eventually slow its dominance. What makes NVIDIA remarkable isn't that it succeeded. It's how close it came to failing. A single bad product nearly erased it. A single pivot saved it. A single software platform reshaped an industry. NVIDIA didn't just ride the AI wave. It built the tools that made the wave possible. And whether this era represents a peak or a beginning remains one of the most important questions in modern technology.